Webinar today. Today we're talking about some pretty exciting stuff. We're going to show you how you can turbocharge your data pipelines with Cube and Dagster. We have Brian and Tony representing Cube and Pedram from Dagster to talk about all things Dagster and Cube. But before we get started, just a few logistical pieces. If you have any questions along the way, definitely enter them in, click submit, and we'll answer them during the live Q&A portion at the end of the webinar. And the recording of the webinar will be available on demand right at our events page, so you can check it out at any time right after the live show. And what we'll be discussing today is what is Cube, what is Dagster, then jump into data orchestration, and then close out with a live demo with the Dagster and Cube integration in action with Q&A to follow. So without further ado, I'm going to hand it up to Brian to get things started. Welcome, Brian.
Hey, thanks, Nathan. I appreciate it. Yeah, hey, everybody. My name's Brian Bickle. I'm the head of partnerships here at Cube. And I have the good fortune to manage all of our ISV relationships and our SI relationships. And, I get to work with Dagster, and yeah, happy to be here today. So as Nathan said, I'm going to start us off by talking about Cube. Cube is a universal semantic layer product, and our mission is to power the next generation of data applications across an organization. To unpack that a little bit, in the modern data world, there are a lot of different ways to use data, whether that's multiple business intelligence tools, embedded analytics, and customer-facing use cases, and now these kind of emerging use cases around AI agents that we're all sort of forced to deal with. And if you think about all of those different use cases, the major challenge that we see in these situations are that customers have a lot of different data sources. And then there are a lot of different downstream use cases that they're trying to map all of these different tools to. And one of the common approaches in the past to solving this was simply doing the data modeling in each of your individual downstream tools, whether that was in a business intelligence tool or with some kind of lightweight data model in a notebook or something like that. This creates a problem because every time we add a new data tool, that involves repeating ourselves and repeating our data model. And it allows for a situation where we end up with a lot of extra work that is unnecessary and a lot of opportunity for models to become stale or inconsistent, and for different teams to kind of end up with different calculations or different metric definitions or potentially different insights and disagreements based on incorrect data. And the big idea behind what Cube is doing is really solving this problem of repeating yourself and making sure that we can separate the data modeling from each individual tool so that you only have to do it one time in the semantic layer, which each tool can then connect to. This also allows for a lot of flexibility because the data models and the architecture can change alongside your needs as you grow your business. Now, from a features perspective, let's talk maybe about exactly what a semantic layer is. We sort of break this down into like 4 major groups of functionality. And as far as what Cube connects to relational databases, cloud data warehouses, lakehouses, query engines of all types, shapes, and then a lot of like oddball sort of time series databases as well. Typically, if something can speak SQL, we can usually connect to it and start to ingest data from it. But once inside Cube, we provide 4 major sorts of functionalities, and these are data modeling, access control, caching, and then APIs. And to start to break some of that down, in our data modeling capability, we are a code-first data modeling experience where users can use either JavaScript or YAML. And YAML is soon to be templated and kind of Python augmented YAML in an upcoming release shortly. You can build your data models there, and then you can version control them in different flavors of Git and move them through development to production branches. Once your data model is in a place where you like it, we do access control That's an access control that's able to do things like column masking, role-based access control that can do row-level security and other kind of interesting like multi-tenant requirements that you may have. And then our caching engine is a product that we built, we call KubeStore, and that is all custom development built around fast pre-aggregation. It is an aggregate aware system. So if you build a roll up for, let's say, a time dimension or maybe a specific dimension that you're interested in rolling up, you don't have to inform any of your BI endpoints or anything else downstream about those. And you don't have to maybe like change your definitions or point to a different view like you would have to do with something like a materialized view as a tactic for trying to solve for performance. Cube just handles that automatically. Whenever a query comes in, we figure out what the most performant either cache or pre-aggregation would be to solve the problem for you, and then we rewrite the query. And then finally, everything leaves Cube as a as a REST API or a GraphQL API, or via our SQL API, which speaks Postgres. And the SQL API is sort of how we get to, most BI tools. That's typically what they're going to be consuming. REST and Graph, of course, may be more suitable if you're building your own custom front-end framework with something like React or Angular or Vue or a myriad of different products you could use now. And then this emerging kind of category of AI agents and chatbots, they sort of split in this. Some of them consume REST and some of them are writing their own SQL. So they might consume different endpoints. As far as like why you need a semantic layer in the modern data stack and really what problems we're trying to solve, the main problems are these sort of 6 areas around consistency, security, performance, flexibility, time to value, and future proofing. And to kind of dig into these just a little bit, the data consistency is typically a point where we're resolving that through better data modeling capabilities and abstracting the data modeling from each individual downstream tool so that there is a better chance at users having a more centralized data model to connect to and not duplicate metric definitions or build inconsistent metric definitions. Security is handled through the access control policies that we mentioned as part of our stack. Again, if you have multiple downstream tools, it's tempting to have different data models in each one, or potentially, have some inconsistency and not be able to keep the data models or the access control policies similar between all of them. Performance is improved in a lot of ways by our pre-aggregation and caching engine. And, with the ability to really not define data models and security within each downstream tool, but do it once, that improves flexibility, time to value, and future proofs you for downstream changes in the future. To kind of orient, maybe where the semantic layer sits, if you aren't familiar with the idea of using one in the modern data stack, we are usually adjacent to data sources, whether that's cloud data warehouses, like I mentioned, relational database products, lake houses, and other things. We are not a transformation tool, but we do typically, I would say, connect to rough-grained transformations through DBT that are like landed back in the data source. That could be DBT, could be SQL Mesh, could be a number of other products. And relevant to the conversation today, we do have an integration with Dagster as an orchestration tool, which we'll talk about later. But again, we don't compete with orchestration. We kind of run right alongside it as part of the modern data stack. And then again, downstream here, you can kind of see all the use cases we talked about already. And with that, I'd like to hand it over to Pedram to tell us about Dagster.
Thanks, Brian. So my name is Pedram Naveed, and I am the head of data engineering here at Dagster. And today I'm really going to be talking to you all about what is Dagster. So to really understand Dagster, I want to first talk about data engineering and kind of where we're at today. I think a lot of us are familiar with the pains of data engineering. There's probably no doubt in all of your minds that there's just too many tools, and it seems to be getting worse, right? Even with the proliferation of the modern data stack, like things have become so fragmented that now, as a data engineer, you have to go and look through, 5, 6, 7 different apps just to find out where something went wrong, what's going on in your data. And so that's just part of the problem, but let's say you do find it. Once you do, you probably don't have the right context to understand what's going on. Traditionally, when we write, orchestration and tasks, we have these big tasks that do a whole bunch of things, but the task doesn't really tell us what's inside of it too often, right? And so if we're trying to understand what happened with one of our models, there's not a clear sense of like which task created that model in our database or what table came from where. And so we lack this full context on what's going on within our orchestration, and things tend to be a bit of a black box. The other side is if teams start to grow, we start to see a lot of siloing happening. And so often there's this very little shared context between teams. Because things are so hard to integrate and we don't have all that context, a data engineering team and data science team tend to work in silos, even though they're often operating on the same underlying data sets. And that lack of unification makes it really hard for teams to know what's going on and to have full context on what teams are working on. And so what we kind of end up with is this terrible dev experience. And I think the peak of it, and probably the worst of it, is how we often end up testing in production. Because these orchestration systems are really tied to specific infrastructure and storage, it's hard to have a local dev environment that allows for easy testing. So for example, I remember when I used to use Airflow a bunch, I had to install Kubernetes on my laptop just to test a pipeline that I was going to push into production. That was a really heavy lift, and often you end up pushing things to production over and over again, just hoping for something to work, which is not something we love. And so those pains are really what drove Dagster to exist. It was a tool designed really to solve these fundamental data engineering problems that in a lot of ways software engineers have figured out answers toward, but we haven't really had the right tools in place. And so what Dagster enables you to do is, you can write your code and test your data pipelines in pure Python. You don't need to start creating all these abstract classes in order to do simple testing. Everything works pretty much out of the box. You've got great monitoring and computation. The UI is really intuitive. And then what's nice is because we look at things in a little bit of a different way, instead of focusing on tasks, in Dagster, everything's based on an asset, which I'll talk about in a second. You do get all these nice ancillary benefits, like being able to track data lineage and metadata. So let's talk a little bit about data orchestration. So there's really like these two overall, I would say, styles of orchestration. There's the traditional workflow orchestration with tools like Prefect and Airflow are really good at. And what they're focused on is, again, that task, right? You would say, I need to do this thing in order to get some outcome. Here's all the steps I got to do, wrap that in a task, call that a DAG, and then you ship it. And because of that, you really only have cron scheduling, right? You can run things on a schedule. And so often what ends up happening is you might say, run my ETL job at midnight, and then by 5 a.m., hopefully that's done, I'll run my modeling job. And then by 7 a.m., hopefully that's done, I'll run my visualization. If you've ever worked with data in that schedule, A, it's not efficient, and B, it's not always accurate, right? If you have to do retries and that type of stuff, like the schedule quickly gets out of hand. And then the other part is always very hard to test. If you ever try to test an Airflow DAG yourself, that that's not an easy thing to do. And because everything is centered around tasks, you kind of lose access to all the things you actually care about. So you don't have any metadata, for example, on the tables and how many rows it wrote, unless you explicitly write all these things down. On the data orchestration side, which is the model Dagster uses, we've kind of spun things around. And to be honest, it took me a while to sort of wrap my head around what this actually means. But once I did, it unlocked a lot of powerful features for me. Instead of thinking about tasks, which is I need to do this thing, let's get it done. In Dagster, we think about the asset, the fundamental thing we actually want to produce. And so by flipping that around, we now have this nice way of thinking about, the things we actually care about. The task is kind of like the imperative way of writing things. The data asset itself, that's a declarative thing that you want. And so when we start thinking about, this table that we need, or that report that we need, or this model that we need, we can start to do a lot of really interesting things. We can start to do upstream and downstream dependencies for that specific model, rather than trying to figure out what task it takes to create that thing. And because of that, we can move outside of just cron, and now we get event-driven and SLA-based scheduling. So if there's a report that is really important and you want it to be refreshed, every hour, you can now do that. And then upstream of that, you can say, here's the minimum set of things I need to run in order to make sure this asset is fresh. And conversely, if you have something that runs once a day and you don't really need it to be that up to date, you can say that this asset doesn't require that much compute, and we'll wait until the next day to get this to run. And then the other nice thing is now, because we're thinking in terms of assets, these things become really easy to test. Especially with Dagster, we have a system of resources. And so you can assign different resources based on your environment. For example, in production, we can say, run Kubernetes, run AWS, run Snowflake. But then when we're testing, we can say, do the same operations, but use DuckDB and use local file storage. And because we've written these things in a decoupled way, it makes it very simple to test and very inexpensive. And this final thing is, I think, what really becomes really interesting, and you'll kind of see this in the demo, is when we start thinking in terms of assets instead of tasks, you now have a system of record. You can start to see your entire pipeline in terms of the things it's producing rather than the things it's doing, which I think is a real big unlock. And so I've talked a little bit high level around what an asset is, but let's take a look at quickly, how do you even write an asset? It's really not that different from what you're probably used to. An asset is just a wrapper around a function that produces the thing that you care about. And so here we have 3 assets: country stats, change model, and continent stats. Once we wrap those in the asset decorator in Python, in Dagster, we get representations of all these 3 assets, and we get the dependencies as well, and then we can materialize these things as needed. And this goes beyond just assets that you care and create about, but also into integrations. So for example, we integrate with a lot of modern tools, such as Airbyte, dbt, Cube as well. And so we have these integrations and libraries, so you can leverage those, and very quickly you'll get your entire dbt repository available to you with all the assets materialized. And now you get introspection into all those models and their dependencies, which is really powerful, because now you can see, this dbt model has this Airbyte orders as a source, while this other one has the users as a source. And so when these are updated independently of each other, you can then incrementally update these things as needed. So that was the talk. Let's jump into a demo. We're going to do this live, so let's see how it goes. We will start with our friend, the terminal. And I just wanted to show what a sample project looks like. I'll actually send a GitHub link to this as well. Really, there's not a lot in here. There's assets, constants, and resources. So I'll start with resources. A resource is really that connection to the outside world. And in this case, I just have one simple resource. It's a DuckDB resource. And this is the 2 lines of code I have to write really to initialize that resource. And if there's a thing that I want that's a little bit more complex, for example, I have this custom Sling resource, I can write the code for that as well. And so for things that are supported out of the box, it's quite simple and relatively easy to get a resource connected. And then for things that might be, your own custom tooling, it doesn't take a lot of effort to create these resources as well. And you can see I have this one function called sync. I ask it for a source table destination file, and then I run some operation on it, and then I return the number of rows in the file size. And then the resource is used by a thing called an asset, right? And an asset, like I said, is just a function that has that decorator attached to it. This example, I'm taking a bunch of data from various sources, such as DuckDB, the internet. I'm downloading from zip files, I'm extracting them. I'm getting some data from Postgres, and I'm getting some data from an API from some SaaS application, for example. And so all of these things can be represented as assets, and using those resources, I can start to extract those assets, and then you'll see that represented in Dagster quickly. So I'll just quickly show what these assets look like, right? I have this asset decorator. I put this little compute kind equal Python, so I get a nice picture at the end. I can give it a group if that's helpful. And really, these are all the lines of code I needed to extract that asset. I can use an existing function I had already in order to download that asset, extract it, and then I just output some metadata. And so I can do that for different types of checklists that I have here. I can even do it for, let's say, DB. I can ingest the CSVs, and I can use DuckDB and just run some straight SQL in there, and then create an asset like that. So overall, it's just very simple Python. There's not a lot of boilerplate around it. You just do the thing you want to do, and you wrap a little bit of decorators around that context, and then you have assets. And so let's see what this actually looks like in Dagster. So I will run Dagster dev here, and I will switch my screen to this one. This is the repo, and if I load Dagster, make sure this is loaded, we're here. So all that work I did in the background, you can kind of see it visualized here. It's really intuitive to understand. All the raw data is my various data sources. For example, these are coming from the web. I'm using Python to download them. I'm using Sling to get data from a Postgres database, and I'm using SteamPipe to get data from Mastodon's API. So easy to connect various different sources and resources to get that data. I can click here and just materialize, for example, only the raw data if I wanted to, or might as well just click materialize all and do the entire pipeline. So this pipeline takes the raw data, DuckDB is ingesting some of that. There's a little bit of light aggregation going on. And then this resource here, Allbirds, that's really the culmination of all this work. We take all this data, we join it together, and we create that DBT model. And you can see this upstream data flag, that's telling me that the data upstream has been updated. And so now we can choose to update this data as it's going through the system. If I go into runs and view runs here, you can kind of watch it through. You can see this little timeline. Things are, sequenced properly. Anything that can run parallelly will. I don't have to specify that like these things should and these things shouldn't. All that sequencing is sort of done for us by Dagster. And then as these assets are created, they're materialized. And what that means is we get this little nice feature here. We see this view asset. We click on that. Maybe I'll make this a little bit bigger. This sites data set, that's an asset, that's a table I've created. There's a table name, database name, and the path, the number of rows. And what's nice is as I run this over and over again, over time, I'll get a plot of the column count, the size over time, so I can keep an eye on these things. If something went wrong, for example, I'll have a sense of like what happened there. The other nice thing is you get lineage for free. So that sites data, it comes in from site description data, which is raw data, and it feeds into Allbirds and then top birds by year. So I'll go back into our asset graph here, and we can see everything is materialized. If, for instance, I updated this raw data set on its own, eventually you'll see once that's updated, Dagster will be aware that tickets and daily tickets are now out of date. Here you can see that upstream data, it's now out of date. And so I can choose to just click these two here and materialize those, or I can click this little triangle and say materialize anything that's missing. So instead of refreshing my entire data set, I can now update just these two. And I think that's it. I'm going to hand it over to Tony for his demo next.
Awesome. Thanks, Pedro. Let me get my screen shared up here. Great. There it is. Awesome. So we've seen how Dagster can keep our pre-aggregations fresh. We can trigger Cube through Dagster and take that pipeline from raw data all the way through to accelerated query cache, and how it's basically all tightly coupled together. And we can trigger it on, as needed and triggered, when something else completes further up in the stack. We don't have to necessarily try again, every 5 minutes during the morning rush, depending on when a file lands. So that can keep us very efficient on the database transformation front. So we're going to see how Cube builds on this foundation and delivers the business value, the last mile through to the rest of the organization. So we'll start by taking a look under the hood of Cube to see, kind of how we get to a pre-aggregation that we want to keep up to date. So first, we've got that duck, or not the duck, the DuckDB model, but the birds model on DuckDB. So that'll be a fun pun here. And so the model what we've modeled out is 4 cubes that pick up that data. We've got bird toots. So this is the whimsical name for the messages on Mastodon. This is not something else for those of you with an eyebrow raised right now. But we've got birds, sites, and species as well from the observations. So these are related together, and we handle those relations through a series of joins. Basically, we've created a couple keys that are going to handle the relationship between those two, or between those 3. Sites are basically where the bird was seen. Species is the type, and more information on what the type of bird that was observed. And then the birds table is just the big table of observations. So we can bring in, we can define things like in our metrics, in our dimensions, we can define those custom keys to help with any composite keys that we need for joins. We can bring in latitude, longitude. We can compute dates. A lot of these string fields actually started out as, a lot of these quantifiable fields that we'd expect to have quantities. They're actually string fields in the source data that brought in numbers or NAs. So instead of nulls or spaces or zeros or something, it was NAs and numbers. So we want to make sure that we're handling those things. And we can do that through Cube's kind of last mile data cleansing. Here in the SQL, we'll just cast those quantifiable columns as integers. And we use try-cast, which is it's going to return null if it's not. So it's not going to error out on us. And then we're also taking some derived metrics as well. So for example, if we can get the number of observations, we can get the number of hours that were spent. People, I imagine, sitting in little hides or sitting on a chair in the field enjoying the nature, counting things. And we can tabulate how long was spent per sighting. We can also see how many observations per sighting. A big flock rolls by, we see 20 birds. That's an interesting point to call out here. So we've got a number of different metrics that we can calculate, and these would be called derived metrics because we're already using aggregates from within the cube data model. So we can do pre-aggregations as well based on that. So maybe we'll take a look in the playground first. So as we're building this data model, jump back to views real quick. As we're building this data model, we don't necessarily need our end users to know that birds, sites, and species are separate tables or even separate cubes, that they just are interested in bird sightings as a concept. And we want to put all those dimensions and measures together in a way that they can just reference each of the fields that they want. So in Cube, we call that concept views. And so we're going to bring through a few fields from the birds. These 5 fields, we're going to bring a couple fields from the sites, latitude and longitude, so we can get a visual on where these birds are being seen. And then we're going to get the actual English name for them instead of a species code from the species table. So over on the playground side, we can run a query against this view and see what are the most common birds. In this case, 2017 is the date range I've got filtered here. How many bird sightings were there? So you can see people were busy out there counting birds. 500,000 mourning doves seen in that year alone, and the list goes on. So there's quite a few birds here. But we can use the playground to kind of test our initial model to make sure that our computations make sense, that the numbers are accurate, that we're computing over in our data model. So if we get a couple of queries that we like here, one of the things that we're going to be curious about and very interested in is a performance aspect. So what's a good candidate for pre-aggregation? Why not go directly to the source every time? So if we can identify a slow query, so for example, in our query history here in KubeCloud, we can see what queries were run, how long they took to run, whether or not they hit the cache, or whether or not they, whether they hit the cache or whether they hit the source upstream database. And for those that did not hit the cache, so for example, this 1.6 second query, not bad, but could be faster. We can go into pre-aggregations and accelerate that. And here we're defining which measures and dimensions we want to include, as well as the time dimension and the grain that we want it to include that at. And that generates a rollup for us, a rollup code in either YAML or JavaScript, one of the two formats that we support at Cube. And then we can go ahead and add that directly to the data schema. We've already got one to play with, but or two. So the pre-aggregations that we have were based on some of the dashboards that I put together for this. And unfortunately, there's a snafu with Tableau right now. So you can see our Tableau external status page is all red. So we're going to be missing that part of the demo today, but I can talk through it. We'll give one more refresh here on the login page and see if we'll get any luck here. So in Cube, we've got the four pillars, right? We've got the data modeling, we've got access control, we've got caching and APIs. And so because all of our APIs share the same caching, the same data model, and the same access control, we're able to make sure that all of our data that leaves Cube is the same, or it's very consistent. So Cube can be that single source of truth that the other downstream applications, downstream users can rely on. So as far as front ends go, it's unfortunate we're getting our time out there. I was going to show one learning I had from this data set, which was the blue jay. So I live over in Washington State, and I've always called these birds blue jays. But apparently that's not a blue jay. I clicked on the map for blue jay, and it was all East Coast. So I was like, what's going on here? So I got to learn that what I had been calling a blue jay was actually a Stellar's jay. And I like those guys because they eat the stink bugs around the house. So big fan of the Stellar's jay. Let's see. And then we've got another tool, Delphi. So Delphi is an AI chatbot that actually only connects to semantic layers. It doesn't connect to any SQL data source. It requires a semantic layer for context, for things like descriptions of the fields, when to use which field, and that's all context that we can provide through descriptions in Cube. So we have questions that we can ask it about the data set. We basically just point it to Cube's API. So the only things I've given it is the REST API endpoint here, and then an authorization token so that it's able to actually reach out and hit this hit our API. And then I can ask questions in plain text. In 2017, which birds had more than 25,000 sightings or 250,000 sightings. And then it goes through the process. So it's very transparent here, which is very important for LLMs, especially at this stage. We want to know what the process is that they're going through. And it even shows the queries that it's running. So here's the actual query that it's running in Cube. We could go look in our query history and see this come in. And then it comes back with the data, and it lists these 7 or so birds. But of course, I don't like to read that. It's just a block of text. So I asked for, give me that, but in a table format with sightings with the number of sightings, so I can read it and understand it better. And it, goes back and provides those for us. We could go, verify those with our playground as well to make sure that it's actually querying the right fields, and see, and make sure that, in 2017, the dark-eyed junco, 200 or 725, 634, 275 or 725, 634 sightings. Perfect. And then the percentage change sighting. So this is more of a, this question isn't straightforward. It's not just give me this data point. It's actually think about it and do a change calculation here. So what percent of change in sightings for the northern cardinal were between 2020 and 2021? So it decided that it had to pull data for 2020 as well as for 2021. And then the sightings, it calculated the difference as 14% growth from 2020 to 2021. So yeah, we've got lots of business value, or the business value that's delivered through the entire pipeline that lands in Cube, and then is extended to the rest of the business apps, and therefore the business users through the data model, through the consistency, through the tight integration of the pipeline. I think that's really one of the keys to how you can deliver the business value and an impactful user experience from your data stack with Cube and Dagster. So I'll go ahead and turn it over for questions now.
Hey, thanks, Tony. Yeah, and thanks, Pedram, for the earlier, kind of demo of Dagster, and also, talk about where the modern data stack is at data engineering. Yeah, just as a reminder, we do have about 20 minutes left in the webinar. If you guys do have questions, feel free to drop them in the QA, and we will go ahead and get to them. And we have a couple here. So we had a couple questions about LLMs specifically, about how semantic layers can kind of help provide data to LLMs and the benefits over doing native SQL querying in an LLM. And I think Tony sort of touched some of that with our integration with Delphi and his commentary about Delphi and their architectural decisions to not connect to SQL databases, but instead connect to semantic layers like Cube and a few other ones that they do. And the reason they do that is to be able to provide the LLM with better context to have a better shot at more correct and more insightful answers versus having the LLM do just like raw SQL generation and attempt to guess at maybe the way that your organization would calculate a metric just by using, essentially its corpus of different ways metrics have been calculated before that it knows about. So that's kind of like one way that works. And there's another question here. The viewer asks, once you've defined all your dimensions, measures, and joins, Cube exposes an API to ask questions of the data. What is the special sauce that separates Cube from other semantic layers or headless BI tools? Well, what I can say is if you think about maybe the cohort of like what other tools do something similar to us, there's some of the more legacy incumbents like AtScale. And then there's obviously like challengers or kind of other competitors to us, like maybe DBT and like what they've done with their original semantic layer, and then what they'll potentially like re-release the new version of that at Coalesce, we all expect. And then there's some more platform aligned semantic layers that I would say things like like what Looker is trying to do, what Google's doing at Looker and trying to split out the semantic layer product. And then also some statements from companies like ThoughtSpot and Tableau at their shows about like intentions to do this. So that's sort of like maybe the landscape. Cube's position is that we are what we call a fully universal semantic layer, meaning that we aren't aligned to any particular data or cloud vendor or to any BI tool or any downstream tool. So that's one distinct sort of difference from maybe like the Looker and ThoughtSpot and Tableau sort of ways that they're approaching it. We're not connected to any vendor, so we're essentially like data Switzerland here in some ways. As far as like the different things that I think that we do that some other products don't do, I would say that the API connectivity options we provide that are very easy to use, such as like REST and Graph and the SQL API, Getting those up and running is just as easy as Tony mentioned in the demo. He creates a data model, and then he's got all 3 API endpoints immediately. He's also got the same security and the same data models in all of them, and then he's got caching with pre-aggregations. So, I don't know exactly sort of like feature comparison versus every other semantic layer out there, but those are like the big things that we do, and they're what we find a lot of people use Cube, the different components that kind of add up to their, helping them build their solutions. Yeah. Okay. There's a question from Emily Jacobs from GoPuff. She asks, is this a demo of the orchestration API? Will we be seeing that functionality? We already have Dagster and we are trying Cube. Looking forward to seeing how these two play together. Please, apologies if I missed that part of the demo. Yeah. So I think we mentioned this. I think Tony mentioned it and Pedram also mentioned it. There is a Dagster component that can invoke a pre-aggregation from Cube. So essentially, Cube, the way we do this is we have what we call our orchestrations API. And I think Tony mentioned that this doesn't have to be like a time-based refresh. This can be an event-driven refresh. So yeah, and the way that you would orchestrate that in your pipeline is, after you've kind of completed your last step with the asset that you're working on, you can just invoke that pre-aggregation refresh. And Pedram, I might ask you to talk about this. I actually don't know what you guys would call that component in Dagster. I know that it's something somebody has to import, right?
Yeah, it would be like a library. It's pretty light. I think just like one line you would probably add, maybe 2. And then you would really just have a dependency on your upstream assets. And then that asset, we would really call that an asset itself. That asset is your materialization. You'd have that to run after everything else is finished.
Yeah, pretty straightforward. Yeah, so, if you have any more questions about that, definitely, if you're already trying Cube, feel free to reach out to whoever you're working with on our side, and we'll help you out. And also connect you to somebody at Dagster if you need help with Dagster. Got another question here. Do you know if folks using Cube with Streamlit, Snowflake data apps, and their LLM capabilities? We do have a Streamlit integration, and Streamlit is not uncommon as a front end for apps built with Cube, and typically like in the embedded analytics or customer facing use case. So yeah, I don't know. I don't have a specific example of like what their LLM capabilities are and interacting with Cube. I will say the most common sort of LLM bridge to Cube is going to be LangChain. That's I think the most common that people are using to sort of build different AI chatbot type experiences.
Great. Well, it looks like that's all the questions we have today. Thank you for spending your hour with us. If you want to come back and check out the recording, again, that will be available on demand on our events page. And these are a few other resources you can check out that will give you all the details about what we talked about today. So thanks again, and hope to see you soon. Have a good day, everyone. Bye.